Hello, and welcome to this case study presentation that's part of CHI 2023. This work is entitled Surfacing AI Explainability in Enterprise Product Visual Design to Address User Tech Proficiency Differences. It was conducted by myself, Sara Tandon, and Jennifer Wang at Microsoft this last year. I'd like you to start by imagining you create products for business end users who access relevant data and make key insights and turn them into meaningful summaries for their businesses. They might be involved in creating customer campaigns and strategy recommendation. Your goal is to empower them to make effective and efficient findings and decisions. Another group you might keep in mind are people who are more adept at data management. They get data into a usable format by ingesting, unifying, and configuring it. They might be statistical experts that can troubleshoot for downstream users. Your initial business end users, however, while they might be experts in their domain, might not be experts in AI and statistics and don't always have access to data experts. They might rely on enterprise products to give them insights into their businesses. In this case study, we adapted this experience from real-world enterprise product scenarios with a range of end users who might engage with a product. We present this visual system created for end users without access to a data or applied scientist. The product takes customer behavior and product information and generates a predictive AI model segmenting customers by their predicted likelihood to churn or to leave a business. In our study, we targeted participants with diverse AI and machine learning familiarity and expertise to gain an understanding of how explanations and design needs might differ between users. We targeted 3 personas to gain an understanding of a range of business experts and help in our context where we needed to categorize user roles to assess various needs. We had marketers who were responsible for customer campaigns and content editing, analysts who access relevant data and turn it into summaries, and we had data wranglers who are statistical experts. We offered them this dashboard on the right that constituted a human and machine scenario wherein users receive the baseline performance or output of a system without much explanation or interaction. We sent participants through this study flow, we gave them a specific scenario, and we gauged their understanding of the charts and what they're seeing. We then asked them to make a recommendation based on the customers that they thought would be the most likely to churn. And if they couldn't, then what they needed to see in order to do that. Lastly, we gained an understanding of our specific participants' tech proficiency. We asked them questions about their personal AI and machine learning use and comfort in their job. We asked them about their coding experience and their experiences with data and statistical interpretation. So what we found was that this bottom chart, which was the chart indicating the top customer behavior factors that influence churn, was the clearest to participants. Our AI proficient participants focused here when making a recommendation, noting that the top 2 behavior factors had the highest influence on churn, and those would be the customers that they would target with those behaviors. However, this grade for model performance was quite confusing. Many participants were confused about what A meant, as there was no scale offered, and some didn't even realize it was a grade at all. However, others relied too heavily on this, assuming that there was absolutely no error in the model whatsoever. The grade system also had Western cultural connotations and wasn't fully understood by some non-American participants. And last, most participants did not interpret the chart indicating customer churn likelihood correctly. The lack of labeling seemed to be the biggest culprit here for misunderstanding, and many targeted a group with a smaller risk to churn simply because it had the most number of customers in that bin. And the recommendations we noticed varied with tech proficiency. Some low tech proficient participants were not able to give a recommendation at all, while the higher proficient participants did target the customers most at risk, but they just wanted more information around the model and the customers. So the persona differences we found were that our analysts and marketers had a limited understanding of AI and lower tech proficiency, but they were very, very confident in the data that they were seeing. Many of them mentioned things that they trusted computers and AI more than humans because it's data, it's objective, it's better at humans at data interpretation. There can't possibly be any error because no humans were involved in it, and it's efficient and consistent. However, our data wranglers with higher tech proficiency mentioned things like taking findings with a grain of salt. They understood that machine learning models come with some level of error, and they were able to make broad recommendations based on those charts because the model performance seemed high. They made these high-level recommendations based on the factors, even though they didn't want more information on the model and customers. So in order to empower our users and offer clearer takeaways, explanations, and conclusions from the model, we ran redesign workshops to identify changes that we could make to the dashboard. We ran these workshops with various experts within our business and asked them to make improvements to reach a broad range of users, especially those with less tech proficiency. We had our experts distinguish between critical and needed changes from future changes to maintain a similar visual experience to original designs. And our goal here was really to reflect a human machine and explanation scenario where humans receive an explanation along with the machine learning output. So we created two dashboards in our redesigns. The first one we can see here as the hierarchy of the churn chart has changed, and the churn chart is now on the left to be read first and has increased labeling. Our model performance, which shows accuracy score, now has a single color-coded metric to explain the model performance. And we have inline information icons accessed on hover within the workflow as a progressive disclosure entry point. Progressive disclosure is contextual information that can help build appropriate trust with our users and knowledge around the model. We offered them hyperlinks with more details to open these side panels that gave them further information on the model performance and history of the model as well. Our second dashboard here included those hierarchical changes and the model performance chart change, as well as progressive disclosure that had our brief jargon-free descriptions of the features. And most notably, our churn chart has now changed. We now segment the total number of customers in a singular stacked chart with a color-coded scale indicating their likelihood to churn. So we then took our redesigns back to participants to see how understanding has changed of the underlying data, if their confidence and trust changed, and we sent them through the same methodology as the original assessment with the same scenario, understanding questions, and asked them to make the same type of recommendation. What we found was that our model performance chart prompted more confidence in participants. Our lower tech proficient users felt the data was trustworthy and they felt more knowledgeable about the data, while the higher tech proficient users felt that it was easier for them to share about the accuracy of the data with their superiors or with people who are not statistical experts. We also found that the on-hover annotations and the plain language descriptions helped our low-tech proficient users to come to similar conclusions to our high-tech proficient users from our initial assessment. Between our likelihood to churn charts, we saw that the increased labeling and on-hover information led to fewer misinterpretations and that users had a quicker response time in giving a recommendation. We also found that this color scale led to instantaneous conclusions by some of our participants, and some felt that the contextualizing amongst all the customers was better. So how did these designs impact understanding, trust, and intentions of our users? We found that our participants had an increased number were able to give a recommendation in the first place, and that our lower tech proficient participants combined risk with customer behavior, which is what our high tech proficient participants were doing in the initial assessment. More participants asked for further data and actionable items rather than just getting caught in understanding of what was happening with the model in the first place. And all of them mentioned trusting the data and now having resources to understand how the data was being generated. So often human-AI interaction guidelines call for clarity, matching norms, and offering explanations, but they don't often offer specifics on how to go about this in a visual design scenario. We felt that our enterprise product scenario was able to help us suggest some specific visual design implications for explainable AI in an applied setting. First, we offer hover annotation utilizing plain language. We feel that this empowers users to make clear, concise, simple conclusions while clearing the visual field and offering information only as users desire it. Second, displaying your model performance metrics as a numerical score with an explicit scale can aid in avoiding over-reliance and any sociocultural ambiguities around grading systems. And then lastly, that progressive disclosure that doesn't navigate users away from the visual context of the model, but is accessed through inline entry points with hierarchical information and jargon-free descriptions can increase user understanding and confidence in data interpretation. We learned that design changes give an opportunity for users with a limited AI and machine learning experience to come away with stronger recommendations and increased understanding of machine learning output while allowing our high-tech proficient users to gain knowledge efficiently without much distraction. Thank you so much for your time.